Okay, in this video we're going to talk about domain and range from functions on a graph. So again, domain is the set of all x coordinates, and then range is the set of all y coordinates. Okay, we've learned that in the past. We're going to write them in something that's called inequality notation. So if you remember inequalities, we're going to be using those again. So the same thing applies as open and closed circles. So for domain, you're going to have your x in the middle, kind of like compound inequalities. And you might have something that looks like this, with a number and with a number. Okay, so we kind of write them like compound inequalities. Again, we could also have x is greater than a number, and x is less than a number. Okay, so those are the three ways we can write domain. So then that means the range is going to be written the same way as well, but with the y values. So you could have x is less than y is less than or equal to a number. Again, you could have y is greater than a number, and y is less than a number. Okay, so those are the three kinds of ways that we're going to be writing domain and range from a graph. Okay, so let's take a look at some examples. If you notice this red piece of paper over here, that's kind of like a post-it note. So you should be using post-it notes with this activity. So raise your hand if you need 2 of them, and then I can get them to you. So again, domain is from the left of the screen to the right of the screen. Okay. So in this problem, I need to go see how farthest right the graph goes. So I'm going to take this little piece of paper and go as far right as it goes. So notice that was at a 1, 2, 3. Okay. And I also need to see how far left it went, because domain is from x left to right. So it goes all the way up to here. So then that will be at a negative 1, 2, 3, 4, 5, 6, 7, 8. Okay. So the values it could be between, it can go from a negative 8, and it can go all the way to a positive 3. Okay? So again, I need to write my inequality little symbol with the x in the middle. And then remember, the signs are always facing the same way, just like compound. So if that's an open circle, that means you're going to have a less than sign. And then if this circle is closed over here, it can be less than or equal to it. Okay? So again, just like compound inequalities before. So now for the range, I'm going to turn this on its side, because range deals with up and down. Okay, so the highest this point goes, I'm going to start from the top and go all the way down until I hit a point. Okay, that was at a 7. Same thing, I'm going to go all the way from the bottom and go until I hit a point right there. So this can be between a 7 and it can go all the way down to a negative 4. So again, your smaller number is going to go on this side. So the lowest it went was a negative 4. The highest it went was a 7 with a y in the middle because it's range. And then they are both equal to, because those dots were both closed in. So it's less than or equal to, less than or equal to. Okay? So let's try this one over here. So for domain, I'm gonna, oh no, let me try and fix that. Okay, I'm gonna see how far left it went. Okay, so that went to a negative 1, 2, 3, 4, 5, 6, 7. So that is at a negative 7. And then see how far right the graph went. So start over here and go to that point, which was a 1, 2, 3, 4, 5, 6. Okay, so the farthest left it went was a negative 7. The furthest right it went was a 6. And since it's domain, x is in the middle. And this right dot was closed in, so it's less than or equal to. And then that 7 was an open circle, so it's just going to be less than. Okay? So now let's take a look at the range values. So again, for range, you start at the tippy top and go all the way down till you hit a point. So that would be at a 1, 2, 3, 4, 5. So the highest the graph went was a 5. and then the lowest the graph went was here at a -7. Okay, so it can go from a -7 all the way up to a +5. So for range, -7 is your smallest number, that +5 is your larger number. Since you're dealing with range, it's a y, and then they're going to be less than signs. But now we need to see if they're open or closed. So since there was a actual line that went through that, that means there's a point there, which means it is less than or equal to it, because there is a point there. Down here, this circle is open, so it's going to just be a less than sign. All right. So let's take a look at some other examples on the back page. So here, these are different because we notice an arrow, okay? So when you've got something that has an arrow, that most likely means that you're not going to have something like this. You're going to have something that's greater than or less than one single number. Okay, so for domain, again, I'm going to go left to right and then stop at that point, which was a -3. Then I'm going to go with this line until I hit that arrow. Okay, this arrow means that I am going up and up and up and up for forever. So this is going to go forever right. And if it's going right, think about how we shaded an inequality sign. If it was right, my arrow was pointing that way. Okay, so my x values need to be greater than whatever this number is down here. So -1, 2, 3. And it also can't be equal to a -3 because that was closed in. Okay, so again, if you see an arrow, that means it's going on forever and ever and ever and ever right. And that's why it is a greater than the smallest number here. Okay, for the range, I'm going to turn these around and go from top to bottom. Okay, so going from the top, I hit an arrow. Okay, and again, that means it's going up for forever. Here, the lowest point was at a 4. So again, when you hit an arrow, you're going to have a letter with a sign and then a number. So range is a y value. Since that problem is going to go up for forever because the arrow is pointing up, that's going to be a greater than sign. It's greater than or equal to because that dot down there is closed in. And then the lowest the graph went was a -4. Okay. So that is how you do problems that have arrows. Okay. So let's do this one together, and then I'll let you try some on your own. So again, domain is from left to right. So the furthest right it went was there. The furthest left, I hit an arrow. Okay, so that means I'm going to have something that looks like this. It's going forever in the left direction. And so that is why my sign is going to be a less than sign, because it's pointing to the left. Domain are the x values. So there is an x there. And then I look at this number over here, 1, 2, 3, 4, 5, 6. So that 6 was closed in. So it can be equal to a 6, but it has to go everything left of a 6. All right. So now let's look at the range. Turn these around. So again, the highest the graph went was a 2. And the lowest it went, it hit an arrow, which means that's going to go forever and ever and ever and ever down. Okay, so if it's going down, that means it's going to be less than. Okay, range deals with your y values. And then now you need to see if it's open or closed in the number. So the highest one was a 2, and it was closed in. So that can be equal to a 2, but it has to be less than it, okay? So again, that is how you write domain and range in interval notation with something that has an arrow, okay? So now, you get to try these 4 on your own, and then I will go over the answers. So press pause and try these. All right, so here are the answers to the first couple problems. So I did my range in red, and then my domain in blue. So if you look at your domain, the furthest left that it went that I drew this line through was a -3, so that's why -3 is here. The furthest right it went should be a 5. It looks like it went a little bit over than a 5. So again, since there was a line there, it means there's a point there, and so that's why I put equal to signs under all of them. For range, the lowest the problem went was a -2, and it was closed in, so I put equal to. The highest the graph went was a 6. Again, it was closed in, so I put 6 with an equal to sign. Over here, my domain, the furthest left it went was a -4, and since this was an open circle, there's no line under it here. The furthest right the graph went was a 6. Again, open circle means there's no line. For range, the lowest the graph went was a 2, and that means 2 was here. Since it was open circle, it was just less than. The highest the graph went was a 6, so 6 again here with an open circle, meaning not equal to. Okay, make sure the x's are with the domain and the y's are with the range. Now, these last two problems, probably noticed something tricky going on. So for domain, if you see the furthest it went, you hit an arrow. And so that means it's going to go forever and ever left, as well as forever and ever right. So if it goes forever left and right, that's like infinity. And so we say it's all real numbers. So anytime you hit 2 arrows, it's all real numbers. For the range, the lowest it went was a -4, and then the highest, when I drew that line, I hit 2 arrows, which means it goes forever and ever up. And so since there's a minimum and then it goes forever up, I'm going to write it this weird way again. So I'd start with y for range, greater than or equal to because it's going up, and up means greater, and the lowest it hit was a -4. For this sideways U-shaped, the domain, I hit an arrow going this way, which means it's forever going to go left. So I knew I had something written like this. The furthest right it went was a 15. So 15 is your number. If it goes left, that's going to be a less than sign. And then again, domain is x. When you look at range, you'll notice that you hit an arrow when you went the lowest, and you hit an arrow when you went the highest. That means it's going to go forever up and forever down. And so that's forever in both directions, which is infinity, which we call all real numbers. Okay? So those are some examples of how you find domain and range from a graph. If you have any questions, let me know. But otherwise, you can work on some practice to get better at this because it is difficult. Thank you for watching.